So I'm just going to go over the final presentation for my Cybera internship for the reporting for the CBS cohort. This was my team. Background, project introduction, models, data pipeline, data visualization, demo, real-time data processing, data analyzing, 3D pose estimation, and future work. So what's the background? We're using computer vision and deep learning to generate insights from live camera feed, combine that data, potentially additional data sources, train a new model that can detect multiple objects quickly and efficiently using real-time image data, process data efficiently, and build data pipelines. What did we do to resolve the problem? Use object detection, YOLO-5 and tracking strong sort algorithms to detect, record, and count number of people in each frame, track the time spent in each area, depth estimation through monocular surveillance camera feed through pixel intensity, perform pose estimation to further try to understand the human behavior with surveillance camera feed, set up data pipeline for real-time image frame processing and storing the outputs in a database for ADA. Project introduction. YOLO-5 is the world's most loved vision API, representing Ultralytics open source research into future vision AI methods, incorporating lessons learned and best practices all over 1,000 hours in development. Training custom YOLO-5 detector for image, batch, epochs, data, CFG, weights, name, and then this is the GitHub library. Strong sort contains highly configured tool state tracker adjusts to different deployment scenarios. Detections generated by YOLO-5 and V7. Family of object detection architectures and models pre-trained on the COCO dataset are passed to a strong sort, which combines motion appearance information based on OSNet in order to track the objects. You can track any object that your YOLO-5 model was trained to detect. Here's the GitHub link. Daylight Depth is an open source toolbox for monocular depth prediction. Relevant work is open source here. Contains the following algorithm: boosting depth code towards 3D scene reconstruction. And then here's the GitHub repo down here. Body Pose 3D Net, described in the case studies for 3D human pose estimation network, aims to predict the scout trend for every person given input image, which consists of key points and connections between them. 3D pose tracking has many practical applications such as action understanding, surveillance, human-robot interaction, motion capture, CGI augmented and virtual reality, assisted living, advanced driver assistance systems, and sports analysis. Coaches, workplace activity monitoring, crowd counting and tracking, and animation. Data pipeline, we had image frames, which led to object detection, object tracking, depth detection, went to the client, restricted area detection. Flink was setting up different alarms. The alarm runner goes for parallel execution to timescale DB, and then it does analytics. It gives bounding boxes with ID, timestamp, number of people, depth frame ID, and frame. And there's real-time image processing here in data, but it's pretty hard to read. This is the detailed thing, image frames and bytes. Kafka sends a message, goes to the client. We have an object detection container for YOLO-5, one for strong sort, a depth detection container for data depth, and then a restricted area detection container. And there's a Flink alarm for number of people exceeding thresholds, a Flink alarm for spike in the number of people, and a Flink alarm for new people exceeding threshold. And another Flink alarm for ID repeating in restricted area. Alarm monitor decides if alarm uploaded DB. Parallel execution activates, goes to timescale DB, and then does some analytics. We used Jupyter Notebook for visualization, RStudio, Plotly, Voila panel. It was web-based and interactive, and Streamlit was also used as well. There's a demo, but I don't have the links to demo, and then we're going to future work. For databases, we have our structure of relational database can be improved, Flink and Kafka system can be improved, Python templates for detections and alarms, functions or APIs to change alarm parameter in real time, pose detection and estimation system, pose estimation Docker image, accuracy for skeleton detection on CBS dataset. Data can be used with pose classification data, and we can model more of the detection for this paddle detection. And that's pretty much it.